and cosecant, and now we're going to do one graph. On the back of your handout from yesterday, these are the 3 steps we're going to follow. So whether it's secant or cosecant, we are going to first graph its reciprocal function. So if it's cosecant, we're going to graph sine, and if it's secant, we're going to graph cosine, as we did before. So you're going to use the key points for sine and cosine. You're going to do the same scale changes, translations, all that stuff, okay? Then, after we have the wave for sine or cosine, we do the next 2 steps. We just add 2 things to the graph. Anywhere you have a 0, I actually do this one first, which means x-intercept, remember, those are going to become vertical asymptotes. So anywhere where it's crossing the x-axis, you're going to make a vertical asymptote, and that's going to be what separates the little U-shapes from each other. Then anywhere you have a max or a min point, that's where the U's are going to bounce off of. So the maximum points will be the bottom of the U's, and the minimum points will be the top of the U's. And again, they'll be contained by those vertical asymptotes. And that's all you have to do, those 2 little pieces to add to the graph to get either secant or cosecant, okay? So we're going to do one of these together. We're going to do this one. Is this equation in a proper form?
No.
Yes.
Yes. Okay. All right. So we're going to treat it like a cosine graph for right now. Okay. It's reciprocal as cosine. Okay. What is the reciprocal of b? 1/2 is going to get multiplied by x. And then a times y, 3y. What are my translations going to be?
X plus pi over 2.
And y plus 0, just y. Okay? Key points for cosine, or sine, actually, they start the same way. 0, pi over 2 pi, 3 pi over 2, 2 pi. And then you need to know the cosine of those radian measures. What is the cosine of 0?
1.
Pi over 2.
0.
Pi. 3 pi over 2. 2 pi. 1. Okay, scale changes first. Translation second. 1/2 times each of my x's will be 0. Pi over 4. Pi over 2. 3 pi over 4. And pi. 3 times each of my y's. 3, 0, -3, 0, 3. Now my translations, the y's are going to stay the same. 3, 0, -3, 0, 3. And then I need to take each of my x's and add pi over 2. Remember, you can do this in the margin with the common denominator if you need to. 0 plus pi over 2 gives me pi over 2. Pi over 4 plus pi over 2. 3 pi over 4. Pi over 2 plus pi over 2. 3 pi over 4 plus pi over 2. 5 pi over 4. And pi plus pi over 2. 3 pi over 2. Okay, I'm going to plot those points. So pi over 2, I'm at 3. 3 pi over 4, I'm at 0. Pi at -3. 5 pi over 4, back at 0. 3 pi over 2, I'm back at 3. Remember, those points should be equidistant. They should be making that wave shape. And that's one period of the cosine function. I'm going to sketch a second one. Okay. And that's enough for my graph. Make sure you put arrows on the end of it. Some of you were missing your arrows on your homework when I graded it last night. Uh-oh, I was right.
Also, do we get the back?
I am going to give that to you today if I can remember where I threw it on my card. Yes. Okay. Now, once we have cosine, let's turn it into the secant function. So anywhere you have an x-intercept, we're going to draw a vertical line. Those are our asymptotes now. Why is that happening? Well, what's the reciprocal of 0? Undefined. Yep. Anywhere where it's crossing the x-axis, I'm making an asymptote. Okay. Then Anywhere you have a maximum or a minimum point, you're going to make a U. And they're going to touch, they're going to intersect at that max or min point. So like at pi. From that point, I'm going to draw a U shape going down. It's going to look like a little parabola. From 3 pi over 2, I'm going to draw a U shape going up. And that, as long as you have one right side up and one upside down, that's one period of the graph. That's enough. You can always sketch more if you want to. Okay, those U shapes should not go past your asymptotes. All right, it's going to look something like that if I draw a few of them. Okay, so remember the graph of secant is just what you see in green on mine. It's just the U shapes. The rest of it is just the process to get to that point. Okay. Period, for these functions, it's the same as sine and cosine. The original period is 2 pi divided by b. The only time we don't use 2 pi is with tangent or cotangent. It's just pi instead. B here is 2. 2 pi over 2 gives me pi. You can also see that in the points we plotted. The distance between pi over 2 and 3 pi over 2 is pi. Domain, again for these, is all real numbers except the asymptotes. The range, the bottom part of the graph, is a negative infinity to negative 3. Use a bracket. Union symbol, bracket, 3 to infinity. To get the asymptotes, I don't usually look at the graph for these. I look at my points I plotted. So remember, the asymptotes came from where it was an x-intercept, where y was 0. So 3 pi over 4 was where there was a 0. And 5 pi over 4 is where there was a 0. So those two are actually asymptotes on our graph now. So I'm going to use those to help me. When we write these forms, we pick one of them as a starting point. So I'm going to pick 3 pi over 4. Plus, it's not the period times k, it's how far apart the asymptotes are times k. So what's the distance between 3 pi over 4 and 5 pi over 4? Pi over 2, k. Where k is an integer. Now it doesn't ask on here, but what would the zeros be? None, because the green graph doesn't touch the x-axis at all. What would the phase shift be? Positive pi over 2 would be the phase shift. Yes. Okay. Ian.
So it's the period over 3 times.
It's the period divided by 2 for these. Yes. Do you guys have your 5-5 homework handy?
Yeah.
Okay. Let's do, because 5th period wanted me to, I think it's probably a good idea. One of the write the equations from the graph problems together like we did last time, real quick. Okay. Let me